Okay. Section 7.4, factored form of a quadratic function. So this might be a little difficult at first because factoring isn't a favorite thing of kids in Math 10, and it's one of the skills from Math 10 that hopefully you were okay at because you're going to really need it in this lesson today. Okay, so it says keep in mind, first of all, when a quadratic function is written in factored form. So instead of the form that you've been used to, instead of y equals ax squared plus bx plus c, they're saying, well, hey, you could get it in factored form. So it says y equals a, and then in brackets, x minus r, and then in other brackets, x minus s. Now remember, all quadratics have to have two x's. Remember, degree 2. So here's the first x, and there's the second one. And this r and this s, if you can look at this picture here, are the x-intercepts. It's where the parabola crosses the x-axis. So this says r comma 0. It's written in the form of x, y, because when you're on the x-axis, y is 0. And then they're just telling you r is the first place where the graph crosses the x-axis, and s is the second. So when you factor them, you can tell your x-intercepts really quickly. So in this form, it could actually be quite handy. So it says the zeros of the function. They call them zeros. They call them roots. They call them solutions. Okay, but the zeros of the function, they're called zeros because remember I told you right here y is 0. So sometimes they call it the zeros. It's what makes the equation 0. The two answers are r and s, because when x equals r, x minus r equals 0, and when x equals s, x minus s equals 0, okay? It says x equals r and x equals s are the x-intercepts of the corresponding parabola. And then, because parabolas are symmetrical, you can find the axis of symmetry by just finding the middle of those two roots. And the way you do that is you just average them. So you add them up and divide by 2. So for example, if this was 3 and this was 5, well, you can probably tell immediately that the middle would be 4, because 4 is between 3 and 5. But if you average them, you would add them together and divide by 2, which gives you 8 over 2, which still gives you 4. Okay, so it's nice and easy. If you can tell by inspection, like you wouldn't have to go through the math to do that, but if it was like 3.29 and 5.87 or something like that, it would be faster to just average them. Now, this isn't written in the form of ax squared plus bx plus c. You can't pull out the y-intercept anymore. Remember how the last letter in a quadratic equation is always the intercept. So they're saying, but you can calculate it. So if you take r multiplied by s, and then multiplied by this a at the beginning, this is that leading coefficient. Remember, this a tells you if the graph opens upwards or opens downwards. You are going to be able to calculate what the y-intercept is. And then lastly, it says if a parabola has 1 or 2 x-intercepts, its equation can be written in factored form using the x-intercepts and one other point. So I want to go through this actually out of order. I know, first of all, I'm going to practice factoring. And then I was going to tell you, I want to do example 2 second, and then I want to do example 2 first, okay? Because example number 1 is kind of hard to start with, but let's practice factoring. Okay, so think back to Math 10. Remember with factoring, we're always looking for two numbers that multiply to the last term and add to the middle term. So in terms of 5, if I make a little factor tree, the only thing that multiplies to 5 is 1 and 5. That's it. 1 times 5 is 5. That's all we can do. And they add to 6, so we're right on track. So in factored form, I write x plus 1. I write plus because it's a positive 1. And I write x plus 5. Okay, so that's factored already. All right, this one. Two things that multiply to 6, and they have to add to negative 5. So they always multiply to the last term, and they add to the middle term. So 6, you can get 1 and 6, because 1 times 6 is 6, or 2 and 3. Now 1 plus 6 is 7, and that's not negative 5, so it's not that. 2 plus 3 is 5, not negative 5. Okay, so 2 times 3 is 6, but 2 plus 3 is not negative 5, it's positive 5. But hopefully you're thinking, but wait a second, negative 2 and negative 3 multiply to positive 6, because when you multiply two negatives, they make a positive, and negative 2 and negative 3 add to negative 5. So, factored form, x minus 2, x minus 3. Okay, last one. How do you get to negative 14? Well, one of them has to be positive and one of them has to be negative. So it could be negative 1 and 14, but that's nowhere close to adding to negative 5. And it could be the other way around, but again, that's not going to add to negative 5. So it could be negative 2 and 7. Negative 2 plus 7 is 5, which is not negative 5. So it has to be the other way around, because negative 7 plus 2 is negative 5, and negative 7 times 2 is negative 14. So factored is x minus 7, x plus 2. Hopefully you're going, oh yeah, I kind of remember that stuff. Okay, so let's try it on this graph. It says, and I'm moving to example 2, and I'll go back to example number 1. So it says, sketch the graph of the quadratic function of x squared minus 3x minus 5. Now, you know what? It says sketch, and that's different than graphing. Sketch means that you don't need graph paper. So I'm actually going to get rid of this graph paper, because sketching is good. Sketching is a lot easier. Okay. Now, if you sketch, you still need an x and y axis, so I'm definitely going to leave that there. Okay. Now, look at how my equation is already in the form of y equals ax squared plus bx plus c. So while I'm in this form, before I do anything, I'm going to pull out my y-intercept. My y-intercept is negative 5. So when you're sketching, you have to say what your y-intercept is. You can't just count squares, because there are no squares. You can put your dot roughly where you think negative 5 goes, and you have to label it. All right, now, my beginning number on this is a 1. So I know now that my graph opens upwards. So it's going to be something like that. All right, so back to my equation. If I can factor it, it makes it nice and easy to graph, because I can put my x-intercepts on, and that kind of gives me a place to guide my pen. So I'm looking for two things that multiply to negative 5, which can only be negative 1 or 5, or 1 and negative 5. All right, you know what? As I'm going through this example, nothing adds to negative 3. So when it comes to drawing this, this is a horrible example. Let's change it to negative 4. Wow. Should have done that before I got on the video. I'm sorry. I don't want to start over there. Change that question to negative 4, because negative 1 and 5 don't add to negative 3, and 1 and negative 5 don't add to 3. So this isn't a very easy question to factor, so it's not a very good example, which doesn't surprise me out of this booklet. But if I changed it to x squared minus 4x minus 5, haven't changed my y-intercept, it's still negative 5, I can say that this is the same as x minus 5, x plus 1. Okay, this one. Multiplies to negative 5, adds to negative 4. All right, so how does this help me? Well, remember that when I am crossing this x-axis, my y is 0. So look at how my left side is 0. Okay, because I want to know where am I crossing the x-axis, and right there y is 0. So if my left side is 0, I have to make my right side 0. So what can x be here in this bracket? What x value would make this bracket 0? Well, it's 5. Because if I plug 5 in here, I'll have 5 minus 5 is 0. If I plug 5 in there, I'll have 5 plus 1 is 6, but I'll have 0 times 6, and I still have 0 on my right side. So 5 is one of the values that will make my equation 0. What about this one? What can I plug into this one? That will make it 0, and hopefully you're thinking it's negative 1. So if I plug in a negative 1, it makes this bracket 0. Negative 1 doesn't make this bracket 0, but I've made this one, so anything times 0 is still 0. So my other intercept is negative 1. Okay, so in your best freehand, you can kind of sketch your parabola. I'm sure you could do better than I can. Not known for my drawing skills. Okay, so my parabola is going to open up. It's going to go through the x-axis at negative 1 and 5. My y-intercept is -5. And I hope right now you can visualize roughly where your axis of symmetry is. We should label it. Where do you think that this goes through the x-axis? Well, remember I said that you can calculate it all the way back to the first page. You can calculate the axis of symmetry. So add up your two intercepts and divide by 2. So add them up, divide by 2. 5 plus -1 is 4. 4 over 2 is 2. Okay, so I know my axis of symmetry is x equals 2. Well, now I know my vertex is also at 2 and something, okay? I should have maybe drawn it a little deeper, but this -5 isn't where the vertex is. My parabola goes down deeper than my y-intercept. So I can calculate this. Does anyone think they know how they can calculate that? If I know my, this is my hint over here. If I know my x is 2, what can I do? You're like, hey, you can substitute it, and that's right. Because remember my equation is y equals, no brackets, y equals x squared minus 4x minus 5. So if I know my x is 2, plug it in. And see what y corresponds to that. Okay, 2 squared is 4, minus 8 minus 5. 4 minus 8 is -3. No, -4, sorry. 4 minus 8 is -4 minus another 5 is -9. So my vertex is at 2 and -9. State the maximum or minimum value. Well, there it is. It's at -9. Yeah, I really should have drawn it more like that because it needs to be down here at -9, doesn't it? Okay, again, not known for my drawing skills. All right. Now let's go back to example number 1. And it says, hey, here's the graph. What's the equation? Now, remember in the form, in standard form, ax squared plus bx plus c. Right now, we actually know what the c part is. It's 6. Okay? But we also know what the x-intercepts are. Remember, that's r and s. So they're -3 and 1. So if I write it in the factored form, remember it's x minus r, x minus s, I'm going to have, here's r, r's -3. So x subtract -3. X subtract 1. So right now I'm at y equals ax plus 3, x minus 1. So one of the biggest mistakes that kids always make is that because this is a 1, it's a positive 1, they want to write x plus 1. And because this is -3, they want to write x minus 3. But remember, you're thinking, what can I plug into that x that will make the bracket 0? Okay, so if I plug in a -3, it's not going to make it 0. If I plug in a 1, it's not going to make it 0. That's why the sign always has to be opposite of the number in the bracket. That's why it's x minus 1. Because that 1, if I plug it in, will make that bracket 0. Because I'm looking for my x-intercepts where y is 0. So make a note of that to yourself. It always is the opposite of what the intercepts are. Okay, now remember how my graph opens downwards? A has to be negative, my letter at the beginning. So I'm going to ignore A for a while, and I'm going to expand this. So in Math 10, we called that foiling. We went this times this times this. So I have x squared minus x. Here's a 3x, and there's a -3. So I have ax squared plus 2x minus 3. Now, we know that this graph opens downwards. So for sure, A has to be negative. It has to be. I need negative something in front of this because, first of all, my graph opens downwards. But secondly, remember how my y-intercept was 6? Okay, it's +6. Even though my graph opens downwards, that y-intercept is 6. Remember how I need to get a 6 at the end. So what can I multiply this negative 3 by to make it 6? Well, hopefully you're thinking negative 2. So once I fully expand it, I have negative 2x squared minus 4x plus 6. And there's my equation. Okay? So hopefully the factoring doesn't hold you back from this lesson. If it does, come and get help. And as always, come and get help anytime you need throughout the lesson. Okay, good luck.